And we're back. Sticking to limits from a graph today, just a little bit of a review of infinite limits, because I know that we've talked before about the fact that one of the times that it's easy to tell that a limit doesn't exist is if you see that there's going to be a vertical asymptote at that point, but I do want to review that. So I'm starting there, and then we'll look at a couple of piecewise and rational functions on page 7 of the limits packet. Okay, so why not start at the top here, number 7. So this says find the limit if it exists. Limit as x approaches -2. I wonder why we would have chosen that specific value, -2. What we're going to see in the days to come is after we've talked about a little intro to limits on a graph, we'll get into algebraic ways to find limits. And we're going to be discussing a lot something that we might use on number 8 called direct substitution, meaning if you can just plug that value into the function, that's sometimes the easiest way to find the limit. Well, here we've chosen a value that would be undefined for this exact expression. So plugging in -2 up on the top, I would get the number -2. On the bottom, I would get -2 plus 2 squared, I would get 0. We talked about very briefly a couple lessons ago how if you do a plug-in and you get a non-zero value over 0, non-zero over 0, there is algebraically a quick answer to this without even thinking of the graph, and that quick answer is that the limit does not exist. I'll put that first because I know that's going to get me credit because technically it is correct, and that's because there is a vertical asymptote. There's a VA at x equals -2, the x value in question. I would have been able to tell that just by looking at this. When I think back to my steps of finding VAs, the vertical asymptote step was set the denominator equal to 0, solve for x. Could I do any better than that, or could I tie this to graphs like we've been talking about very recently? Well, yeah. We used to do a little sign analysis if we wanted to come up with what this thing would look like. I know that it has, let's put its asymptotes on a sketch first. I know that it has a vertical asymptote at -2. We've been talking about that. Does it have any horizontal asymptote? Well, for that, think back, we used top-heavy, bottom-heavy balanced rules. You are bottom-heavy in this function. You have a higher degree of x on the bottom. So that means there is automatically going to be a horizontal asymptote right along, shouldn't be floating, it should be right along the x-axis at y equals 0. In between those dotted lines, right, we've got these hyperbola curves. What turns out happening is this denominator is always positive. Really, if you plug negative values into the top, you're going to get a negative back. So a sign analysis would give me a negative here. Plugging in anything between -2 and 0 would give you a negative as well. And anything above 0 would give you a positive output for this fraction. So thinking back, if I had to graph this rational function, you're going to have a completely negative hyperbola branch. You will have a completely negative part of a hyperbola branch. It's going to hit what would have been, and if I plug 0 in, I get 0 over 4, so it'll hit the origin 0, 0. It's going to break a rule and cut through the horizontal asymptote. But if you recall, horizontal asymptotes can be broken in the middle. They just need to be obeyed to the two far ends. So it'll come up from above and then approach the asymptote from the other side. Well, that was fun to walk down memory lane. All that being said, there's another answer to this question. Since the two sides agree and they're just decreasing forever around that asymptote, you can also say negative infinity is that quote-unquote limit. If that was too long-winded of a process, just look at a graph on a calculator or on Desmos. You can see that from both sides of the x value in question, you're going to have that decreasing forever behavior. Okay, for number 8, 8 is kind of the oddball in this set of questions because it's not one compact rational expression. So I don't even want to think about the graph for a second. I want to give you a sneak preview into tomorrow's lesson. Tomorrow's lesson, we're going to talk about some properties of limits that are algebraic. And spoiler, because I'm going to give it away now, one property is that if you have the limit of the sum of terms, you can actually split that up into two separate limits. We're going to eventually practice with the fact that you can make this the limit of, as x approaches 0, of -3, plus the limit as x approaches 0 of the other part, of an easy-to-handle rational function, 1 over x to the 4th. So, man, -3, there's nowhere to plug a 0 in there. That's just a straight horizontal line. Just straight across, y equals -3. What's the limit as x approaches 0? Well, the function everywhere is this number. This is actually going to turn out just to be -3. How about this function separately? Think of 1 over x to the fourth. That is a hyperbola, but it always stays positive. If I raise any number to an even power, I'm going to get a positive back. You actually have asymptotes on the x and y axis, and it's going to grow forever around 0. The behavior of the function around that, if you split that up around 0, is going to be that it increases forever. Well, -3 plus numbers that are getting bigger and bigger and bigger, this limit is infinity. And if I were to graph the entire function, you would get a function that's shifted down a little bit, but it rises to both sides. So if you don't want to have to deal with all that work, you can look at a graph and confirm that you could put DNE for this answer. Or as always, if the two sides agree, you can put something like positive infinity. Okay, back to stuff like 9 and 10 where you just have a rational function as all one fraction. Can I put the safe answer for number 9? So can I put DNE and be okay? You can, because if you did a plug-in with 5, you would get 1, which is a non-zero number, over 5 minus 5 over 0, which means there's an asymptote. And by asymptote rules, there's a VA at x equals 5, setting the denominator equal to 0. So DNE, I might as well put it now, safe solution. Is there a type of infinity? If this were a multiple choice question and positive or negative infinity were possible answers, I wonder if I could pick either one. Well, if I think of the way the graph looks, it has a VA at 5. It is actually always negative before the asymptote, and it's always positive after. You get this kind of picture. The limit as a whole does not exist. This graph applies to both 9 and 10 because you have the same expression there. So the two sides just don't agree, and the only thing you can put for 10 is DNE, if it's just the limit as x approaches 5 from both sides. But if we're talking only from the left, I just want to note that you could also put negative infinity for that answer. So a bunch of questions so far where DNE has been the safest thing to put. Is this the same case in 11 and 12? Well, sure. If you do a plug-in of 1, you get 5 over 0. Non-zero number over 0, I'm just going to write the safe answer, DNE. Is there a more descriptive answer? As you're around the asymptote, you have an asymptote of VA at x equals 1. This graph has just a 5 up top and a denominator that's always positive. You're positive everywhere. So here's one where we can be more specific, right? The two sides are increasing forever around 1. So you could say positive infinity would be a descriptive way to answer that. And then the last one, for 12, I'll just split it up into 2 parts. It's the limit as x approaches 1 of the number 2. And there's a property that says we can write this as a separate limit as x approaches 1 of the fraction, 5 over x minus 1 squared. Well, 2 is always a 2. That's a really boring horizontal line. Sorry that I'm being so mean about it. It's not mean to call a graph boring, but it stays at 2. This part is always going to be positive because of what we got in the last question. So 2 minus infinity, if I were to graph this entire function, you get a function that decreases forever around the asymptote. It's going to look something like that. So negative infinity is what I should have put. That would work, and then DNE. Okay, lastly, I consider these 2 questions at the bottom of the page review questions. Try your hand at sketching the piecewise function. See if it helps you. Let's use a combo of looking at the graph and maybe also algebraically looking at the equation to see if we can get some of these answers for limits and function values. Okay, piecewise, been a while. This is a throwback. Why don't we start below 0? Can you graph x cubed minus 1? So that is, I think back, and it's a cubic function shifted down 1 unit, so it would have had an inflection point on the y-axis at 0, but notice this is not a hard inequality. So let's go up to an open dot of a S-curve that shifted down 1 unit, but I only want to graph it on the left-hand side. Your parent graph has a point down 1 over 1. That's my best sketch of the left side of that S-curve. All right, now in the middle, 0, when x is 0, y is 0. So here I was saying don't fill in this point, and that's especially important because we are going to fill in this point at the origin. When x is 0, we want y to be 0, so that checks off that point. Lastly, a square root graph. I call this shape a French fry. It's like a half parabola on its side. What do we want to do for this graph? Well, it needs to be shifted down 2 and to the left 1. So it would have been to the left 1 this way and down 2, actually overlapping that point. You'd be going over 1, up 1. You'd be going up 2 from the anchor point and over 3. I can confirm that this would be a point on that curve by doing a plug-in. Got a little sloppy at the end there. If I plugged in, I guess, x equals 3 to this equation, you get the square root of 3 plus 1. Square root of 4 is 2 minus 2. You can confirm you get a point at 3, 0. It's kind of funny because when all said and done here, this looks like it could have been a nice continuous curve. It's just missing a filled in point there. Now I wonder, does that affect the limit? Well, there will be a limit here. There will be a function value there. They're just not going to be the same exact thing. So let's try to get these limits. Looks like we need the limit from the left and the right of 0 and 0 as a whole. Well, from the left, that's what's happening around the x value. Approaching 0 from the left, a guy's walking up the function. His limit is this y value, -1. Would you agree that that's the same as the limit from the right? Because I would. It's not like you're going to jump up to this blue point automatically. You're walking along the function. As soon as you hit the y-axis, you're down at the y value, -1. Limit as a whole, I mean, as long as I got the same answer for A and B, I can trust the answer to C to be -1. How about limit as x approaches -1? I don't see anything funny about this one. From the left and the right, it looks like this y value, -2. So that one's okay. What about the next one? What kind of an answer can we get for this? 1 from the left. X approaches 1 from the left. Well, really, 1 from the left would have been the same thing as 1 from the right. And it's going to be a decimal value. Let's try to get it exact. One thing I'll do, I'll circle this, and again, I'm giving you a sneak peek into finding limits from plugins called direct substitution. From the left and right of 1, we are on this part of the piecewise function because 1 falls above 0. Why don't we try a direct substitution of 1 into that circled expression? So square root of 1 plus 1 minus 2. Square root of 2 minus 2 is going to be your exact value. If you want to get an idea of where you're at and round the decimal, that gives you -0.59. And that looks like it's feasible within that diagram. Is there an f of 0? Well, yeah, we've been neglecting this filled in dot right here. And f of 0 neither comes from this part of the function nor that part of the function. It comes from this guy right in the middle. F of 0 is 0. So you'll see some piecewise functions, I think, in the examples to come. What about 14? Rational function for us to graph. So this kind of reminds me of some of the questions we were doing above. I bet you when we get to a question like B, maybe if you think that a VA is going to be there, we might get some sort of value, but let's see what happens. Will there be a VA at x equals -3? Well, if I were trying to simplify this algebraically, I guess, can you try and factor the top? Because if I were looking for VAs, HAs, and holes of that function, my step 1 would be to factor and look for holes first, see if anything cancels. And what do you know? Up top here, x plus 3, x minus 2. So actually, I'm not really dealing with any kind of hyperbola at all. Here's a graph that'll be a little bit interesting at the x value -3, but you're really just graphing the line x equals -2 as long as you're not breaking any rules, as long as you're not dividing by 0 and you have x does not ever equal -3. Well, if I'm graphing y equals x minus 2, let's do the graph first. That's a straight diagonal line shifted down 2 units. And the slope, maybe I'll get help with this and use the line tool, see how good I am at this. The slope is 1. I want to see, maybe I'll extend it like that. I know I'm going to have to do a few revisions to this. That looks pretty good there. Will it let me click? Thanks for bearing with me here. And I'll just extend it up the page a little bit, try to stay as straight as possible. And then will this cut it? I mean, if I graph this on a TI-84 calculator, that's what it's going to give me. But I do have to account for the fact that x is not allowed to be -3. So why don't we open up a dot? Let's open up a dot here, pretend like we knew it the whole time. And you have a hole with the coordinates -3, -2, 3, 4, 5, -3, -5. Now, let's see how that affects a limit. Is there a limit around both sides of 2? Well, from the left and right of 2, it looks like your limit is going to be 0. From the left and right of 2, you're kind of just on the x-axis. So I think that one's pretty good. Limit, here's what we were talking about before. Limit as x approaches -3 from both sides. Is it okay that there's an open dot there? Yes. Limits don't care what's actually happening at that x value. Limits care about the neighborhood around that x value. Where would two people be meeting up? So let's settle on -5. If I ask you what is f of -3 skipping down, well, I don't see one. No one set one up. So it doesn't exist, which is fine to put, or I'll just put UND. It's not defined. And f of 0, I don't think there's any fancy tricks with f of 0. I can look at the graph, or I could plug 0 into any version of this to get 0, comma, -2 as the point. Enjoy your day. Take it to the limit. I'll talk to you soon.